Alright, so we are going to now look at how Lewis dot structures can tell us a little bit about how that structure is made and also the polarity of it. Remember, polarity just means electrons are being moved from more, pushed from more in one area than the other. Okay, so we're not really looking at Lewis dot structures for ionic bonds, just covalent bonds. So two nonmetals. So you can see examples here. These are all nonmetals bonded to nonmetals. So I just want to give you a couple tricks of the trade, try to give you some more examples, and you can see how it works. Okay, so there is a great PowerPoint, and I'll probably go over it in class about the rules and everything like that. But I thought using examples might help out. Okay, so we have CH4, and all we have to do is try to draw this. And the whole idea is we want to make sure that the central atom can bond the most. So we look at C, and it's in column 14. It has 4 outer electrons. It needs 4 more to get the 8 that it would love for an outer shell. Okay, so it needs 4 more electrons. Each bond would be an electron. So it needs 4 bonds to become happy. Okay, hydrogen is in column 1. It needs 1 bond. So hydrogen has less bonds than carbon, so it wouldn't really be a good central atom because it can't bond to more than one thing. So you'd want to put maybe something like carbon in the middle. Okay, carbon has 4 electrons, so I'm going to space them out so that you can see them. And also 4 electrons, 4 bonds. That's why there's a 4 there. So it works out pretty well that hydrogens can go over around here. Okay, now hydrogen has 1 bond, so I'm going to put an X just to show the difference in their electrons. Okay, so basically hydrogen is like, I want 1 bond, 1 more bond, just 1 bond, so 1 electron, and carbon needs 4. So if they just connect here and they share each other's electrons between here, they're going to be happy because now hydrogen is using carbon's electron to have a full outer shell of 2, and carbon is using the electrons that hydrogen has, 4 of them, to have a full outer shell as well. So they're sharing electrons. So now the question is, polar or nonpolar? Okay? And the answer would be, well, you got to look for a couple things. First of all, if there are any electrons on the central atom that are not bonded, it's automatically polar. I don't see any electrons on carbon that have not been associated with a bond. So therefore, that would make it nonpolar. But you got to look at other things too. You have to look at if this is symmetrical. You can see that there's H's all around, so therefore it has no electrons on the central atom, and there's symmetry, meaning the electrons are spread out evenly. So we're going to say this is nonpolar. Okay, that's why this is a gas at room temperature, not very sticky. It's not polar. Okay. Now, if I took this and I said, well, what if I made this a 3 and I put a Cl? So I have a Cl now here. Well, now this would be polar because it's not symmetrical. This guy likes electrons more than H. So therefore the electrons would pull over here more, making it have a polarity to it. Okay? So therefore it would make it polar. Okay? So there would make it polar. See, one element can change that. Okay? Now, I want to go back though to looking at this and looking at the example here. So I'm going to go back to H, and we know that's nonpolar. I'm going to go here and take away that. Now, look at SiCl4. These two are comparable because they're in the same column. Si and C are both column 14. They both want 4 bonds. Chlorine is in column 17, and it wants 1 bond to fill its outer shell because 7 plus 1. Hydrogen is not in column 17, but it acts just like 1 because it needs 1 bond to be happy. So these guys act just like it. So this is going to be exactly the same type of structure. I put Si, I'm going to move it over here now. I put Si in the middle, and I'm just going to bond it to 4 Cls. So I didn't really put the dots this time. I just put the lines because that indicates 2 electrons. 1 from Si and 1 from Cl. Notice that there are no electrons not being used on the central atom, and it's symmetrical. So this again is nonpolar. Okay? So try to see some similarities, and you can go, okay, it's the same thing, because if they're in the same column, they're going to act the same way. So we can see that nitrogen and phosphorus are both in column 15. They want 3 bonds because they have 5 outer electrons. They need to get to 8. Okay, hydrogen and fluorine, just like hydrogen and chlorine, just want 1 bond. They also do. So that's why there's a 3 there. 3 accommodates the 3 electrons that nitrogen needs, and 3 accommodates the 3 electrons that fluorine needs. Okay, so you can see that I'm going to use the central atom that needs the most bonds. Nitrogen needs 3, hydrogen needs 1. Phosphorus needs 3, fluorine needs 1. So again, I'm going to have nitrogen in the middle for this one, and I'm going to have phosphorus in the middle there. Now, phosphorus has 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to surround my hydrogens here with an electron, hydrogen. You can see that I'm just going to move them there. Connect the dots, okay? And phosphorus, I am going to put my fluorine, and my fluorine actually has 7 electrons on the outer shell. So I'm going to put 7 here, and another fluorine here, and I'm just going to put an X with 7 electrons all around it, and then another fluorine here with an X, and you can see, probably tell now, that they're going to bond here to make everyone happy. So phosphorus has, this counts as 2, 4, 6, 7, 8. Fluorine has 2, 4, 6, and this counts as 2 because it's going to share 1 from phosphorus. So that makes it 8. 2, 4, 6, 8, 2, 4, 6, 8. Over here, nitrogen has 2, 4, 6, 8, and hydrogen has 2, 2, 2. Everyone's happy. So now the question is it polar or non-polar? So there are electrons that are not being shared. So therefore, automatically polar for both of them. Okay? So those are just some examples of how that works. Take a moment to take a break or whatever. I'm going to give you some more examples though. All right? So here we go. Let's try a few more. All right, so let's try, how about SF2 and OBR2. Notice that S and F are both in column 16. They want 2 electrons. Look at the 2. And BR and F just want 1. So this works out well. So S is the atom that wants the most bonds, so it's in the middle. And so is O. All right, I'm going to put the electrons out. So it's got 1, 2, 3, 4, 5, 6. And I usually do pairs because electrons like to be in pairs. Oxygen, same amount of electrons. Okay? And then I'm just going to put a BR over here. Whoop, BR, and a BR. And I'll put an F here, and an F here. They have 7 electrons, so same thing as the other one. And then 7 electrons. I'll get rid of this hydrogen right there. BR is in the same family as F. It has 7 electrons. So I'm going to put 7 out. Okay? So now we can move these. I'm going to move these dots though because it only wants to bond once on both sides. So I'll move those other 2. So it still has 2, 4, 5, 6 electrons. I'm just moving 1 out of the way on both sides. So now they're going to bond, right? So they need, sulfur needs 1, 2 bonds to make 8. So 2, 4, 5, 6, 7, 8. 2, 4, 5, 6, 7, 8. And then bromine has 2, 4, 6, 8. 2, 4, 6, 8. They all have 8. Perfect number. They're good to go. So the question is polar or non-polar? So the idea is it's symmetrical, but you have electrons that are not being used for bonding. So these are both polar. These guys are not being used. So therefore, you have electrons more in the middle, then they're not evenly spread out. Okay? So there's some more examples. Let's do a few more. All right, so these are a little bit more tricky. So let's try O2, N2, and CO2. So all of these we've been doing one line for each element, but notice that oxygen doesn't have a central atom. There's two of them, so you just have to draw them here, right? And nitrogen, nitrogen, right? Carbon and oxygen, well, C can bond 4 times, oxygen only twice. So I'm going to put the middle atom here, right? So now I'm going to put the electrons on all of these. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Nitrogen has 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Carbon has 4. And then oxygen, I'll move oxygen out of the way a little bit so you can see it. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now notice I just put them around. You can put those two up here. You can put those two there. You can move them anywhere you want. Okay, it's not that big of a deal. But I just want you to see that oxygen needs 2 bonds each to be happy. So that's why they're going to bond together twice. Okay? This is non-polar because it doesn't have a central atom, so there is no electrons that are being, it doesn't matter that their electrons aren't being shared because it's symmetrical. There is symmetry here. So these electrons that are not being shared are the same over here, so they're spread out evenly. If there was a central atom that didn't have electrons being shared, then we have a different issue here. Okay? Same thing with nitrogen. So we got nitrogen needs 3 bonds each to have a full outer shell. So they're going to bond 1, 2, 3, because that's 6 total electrons, 7, 8. 6, 7, 8. And since there is no central atom in there, and they are very they're symmetrical and there's no central atom, it's non-polar. And that's why these guys have very low boiling points, right? We talked about that. And that kind of shows you there's no charge, they're not sticky. It's not like one side's a plus and one side's a minus, right? Those go away, right? They're not there, right? And then same thing as you can tell with oxygen, carbon needs 2 bonds, and oxygen needs 4 bonds. Carbon, or oxygen, needs 2 bonds each. Okay? So to make that happen, oxygen needs 2, 1, 2, because 2, 4, 6, 8. Over here, 2, 4, 6, 8. And then carbon's happy as well, 2, 4, 6, 8. And this also is non-polar. I'll just put NP here. Non-polar because the central atom has no electrons that are not shared, and it's very symmetrical. Okay? So take some practice on this, but after you start doing this for a while, you'll start realizing there are patterns to this. And remember we talked about elements in the same column will always have very similar properties in terms of, not properties, but in terms like Lewis dot patterns, where if it has 4 electrons, I can easily, like it has 4 outer electrons, I can easily replace this with Si, and it would be the same thing, because it needs 4 bonds. I could change N and N, and I could put P and P there, because they both need 3 bonds. Oxygen, I could put sulfur there. Okay? So once you know that, then it limits the changes that you could do. Okay? So hopefully that helped. Good luck.